Hello learners, welcome to the another session, that is life cycle assessment measurement techniques. So we have understood that what is meant by the life cycle assessment and what are the criteria which are behind for the life cycle assessment. From a standard perspective, life cycle assessment is dealt with under the umbrella of the ISO 14000 series. So the main documents which are involved in the life cycle assessment are ISO 14040, for that is the Principles and Framework 1997, and ISO 14041 gives the details about life cycle inventory analysis, that is 1998, and ISO 14042 life cycle impact assessment 2000, and ISO 14043 life cycle interpretation in 2000. So for this life cycle assessment, data quality requirements are highly important. That means the data quality requirements should be documented to define the required properties of the data for the study. That means the data quality is most important because it has a significant influence on the results of the LCA study. So the requirements of the data quality have to be determined at the beginning of the study itself. In general, data quality is a trade-off between the feasibility and the completeness. So the quality of a data set that can only be assessed if the characteristics of that particular data are sufficiently documented. So data quality does therefore correspond to the documentation quality. So the issues which are considered for the data quality are, that is the acquisition of data. That means the data should be measured, calculated or estimated. How much of the data is required, whether it is a primary data or how much data is taken from the literature and databases, that means that is for the secondary data, and also depends upon the time reference. That means when was this data was obtained and have there been any major changes since the data collected, that might affect the results definitely. And then geographical reference also have to be specified. So that means from which country or which region is this data generated or relevant. And next come to the technology. That means best available technology is the secondary data from the literature or the databases representative for state of the art technology or for older technology, which one we have to select. And also most important, precision is required. That means is the data a precise representation of the system or not. If you will come to the completeness, are any data missing or not? How are data gaps filled? So representativity and consistency and reproducibility, so these things matter a lot. That means whether the data is representative, consistent and can it be reproduced. So the most important phase of this analysis is data collection, and also it is more work intensive and time consuming process of all the phases of this life cycle assessment. For example, the collecting quantitative and qualitative data for every unit that process of the system. The classification of data for each unit process is like energy inputs or raw material procurement or ancillary inputs or other physical inputs, products, co-products, waste, emissions to water, emissions to air and soil, and other environmental aspects, and practical difficulties for data collection have to be documented specifically. And next comes into the picture is the calculation of LCI. So before calculating the life cycle inventory, they have to check for data validation, that is validating the collected data, that is a continuous process. This can also be done with the mass or energy balances as well as with a comparison to similar data. These methods have to be in place to handle data gaps. So the relating data to unit process, it definitely providing data functional unit. That means the data has to be related to the particular functional unit of that process, because these steps which are necessary to generate the LCI for each unit process and for the overall product system. So the life cycle impact of the whole product system is the sum of all LCAs of all involved processes. Now we will come to the life cycle impact assessment. So it identifies and evaluates the amount and significance of the potential environmental impacts which arises from the life cycle impact. And then the inputs and outputs of the first assigned to impact categories and also their potential impacts that are quantified according to the characterization factors. So, the measurement techniques of the life cycle impact assessment is mainly based on the quantitative and qualitative methods which are characterization of environmental impacts of a specific system. So, in this phase, the quantified mass and energy balances of a particular system in the life cycle inventory phase that are combined into the specified environmental effects. So, it consists of the classification step, characterization step, normalization, valuation. So, these 4 steps are mainly involved in the measurement of the life cycle assessment. So, first we will see the classification. We know that it is a qualitative technique definitely, where the environmental burdens that are compiled to categorize in the various impacts to specify adverse effects on depletion of natural resources and also environmental and human health. So, the compilation that can be done based on the adverse impacts of the burdens to identify a similar burden which is common to a number of impacts. I would like to give you an example, that is volatile organic compounds VOCs are there. They are responsible for global warming and ozone depletion. So, the problem oriented approach is the method which is used to classify the potential impacts. And also the considerations of the life cycle assessment are abiotic resources depletion and global warming, ozone depletion, some criteria is there, and also acidification, eutrophication and photochemical oxidant formation and effects on humans, that is human toxicity, and also effects on environment, that is ecotoxicity, land use. Next comes to the characterization step. So, in this step it is a quantitative step. It definitely measures the total impacts of the environmental burdens that will be predicted in LCI analysis. So, this phase of analysis is quantitative in nature and that could be based on the scientific findings on the predicted environmental impacts in the inventory analysis. In this, the problem oriented methodology, the effects are measured relative to a reference. For example, for the determination of the global warming potential of gases like methane and volatile organic compounds like carbon dioxide is a reference gas. So, the overall impact can be calculated by the equation which is you are seeing on the screen. So, everything has been clearly mentioned there, and then there is a relative contribution of a burden is there, and then impact. So, the life cycle impact analysis, this method is not well established and it is reorganized that there is a comparatively huge uncertainty in impact categorization, environmental burdens and parameters for the modeling and the type of models that are used for the impact category. So far, that is a uniform system for the evaluation of substances is one of the models which is in practice. Next is the normalization. So, this can be carried out in compare the data to the correct magnitude of adverse effects in a given system, and it can be performed on the total emissions in a specific area over a given period of time. For example, entire emission of global warming gases and natural resource depletion can be measured relatively, whereas impacts like acidification and the human toxicity are difficult to measure at the global level because normalization methods may not be reliable processor for the comparing the adverse effects of the system. So, the identification of significant issues, all these things have to be taken care of. So, the initial step of the life cycle interpretation stage is to organize the results from the LCI and LCIA and identify the significant issues or data elements that contribute most significantly to the results of both life cycle inventory and also life cycle impact assessment of each product, process or the services. So, the identification of significant issues that guides the evaluation step because of the extensive amount of data has been collected, it is only feasible within the reasonable time and resources to assess the data elements that contribute significantly to outcome of the result. So, these issues should be determined in accordance with the goal and scope definition and iteratively with the evaluation phase. So, the results will be presented in the form of data lists, tables, sometimes bar diagrams, or otherwise the whatever it is the convenient forms which are feasible. And they can be arranged according to the life cycle phases, different processes, types of environmental impact or other criteria can be followed. And next one is evaluation. The aim of the evaluation is to enhance the reliability of the study. It is a final and most subjective step of the impact assessment. In this, the relative significance of different impacts is weighted so that they can be compared among themselves. So, this will be useful for the completeness check, sensitivity check and also consistency check. So, resulting of these criteria, different environmental impacts are reduced to a single environmental impact function. So, it is a measure of environmental performance. This can be represented by that equation which you are seeing, where Wk is the relative importance of impact, that is Ek. There are other techniques for the valuation process which are mainly based on expressing preferences by the decision makers or by experts or by general public. So, there are multi-attribute utility theory, analytical hierarchy process and impact analysis matrix cost benefit analysis, and also contingent valuation are some of other methods for the valuation process. And the reporting stage. The result of life cycle assessment should be assembled in a comprehensive report to present the results in a clear, transparent and structured manner. We know that what is the structured manner? It is an organized manner. The report should present the results of the LCI and LCIA and also all data methods, assumptions and limitations in sufficient detailed manner. So, the reporting of the results should be consistent with the goal and scope definition what we have already learned. The type and format of the report is defined in the scope definition and also will vary depending on the intended audience. The ISO 14044 requires full transparency in terms of value choices, rationales and expert judgments. If the result will be reported to someone, that is who is not involved in LCA study, that is a third party, normally we can call them as stakeholders, any misinterpretation of the result should be prevented. Dear learner, you must have understood about the measurement techniques of LCA. So, I would like to conclude that the LCA will contribute substantially to the quality of integrated decision making, particularly against the context of government's commitments to the sustainable development. As an additional tool in the environmental management toolbox, it will definitely assist in raising awareness on integrated environmental management and sustainability issues, and also will definitely encourage a greater degree of interdisciplinary linkages what we have studied. Thank you.